And welcome, Mindsetters, to this session of Learn Extra Live. We're here doing the grade 10 life science. And I've got Cheryl here. It's her first time, so Mindsetters, make sure you get on the page and show us some love and say, hey, let her know how she's doing. And on that note, Cheryl, what are you doing today?
Hi, good evening. We're going to be looking at the circulatory system today, but most importantly, you have already done it. So what we're going to look at is revision, a couple of questions that can prepare you for the exam. So just basically an overview of what you have already done.
All right, awesome. So while Cheryl makes her way across the board,
Thank
there
you,
you
Ty.
go. Mindsetters, you know the drill by now. Make sure you get on the page. Let us know what you're thinking. If you're lost in it, if you need help, if there's something that you would like to specifically ask, make sure you get it to me on the page and I can get that to Cheryl, who will help you out. But as I always say, Mindsetters, if you don't post, I can't help you. So post. And yes, we're still pushing to try and get to 15,000. So make sure you get your friends to get another friend on the page and get chatting to us. But on that note, this is where I hand over to Cheryl, who's going to continue the show. Take it away.
Thank you, Ty. Welcome on this really cold Wednesday evening. I'm sure you guys have had such an exciting week with the snow yesterday. I know at school yesterday it was absolute chaos, all right, with all the different weather that's happening at the moment. But it's time now to just settle back and get a nice cup of coffee or something and just relax, and let's go over what we've done throughout the year so far. As you will see tonight, we are going to be looking at just a revision of the circulatory system. You have done already some of the things already, as you will notice when we look at some of the topics that we're going to look at. You have done it all before. You've looked at the heart, the structure of the heart. I know you were even very lucky enough, all right, to see a dissection. We're going to look at the blood vessels. Just again, quickly, just to recap, we're going to look at the blood, especially the plasma and the cells, and then lastly, the lymphatic system. So we're not going to really do as much teaching of those structures tonight, but we're just going to quickly look at revision. You guys are going to be writing tests soon and how to study for those. Okay, so now when we're looking at, all right, the circulatory system, just quickly go back, all right, remember just terminology that you need to learn: the open circulatory system, the closed circulatory system. Remember the open circulatory system, all right. I'm sure some of you have you've squashed an insect before and all the yellow and the goo has all come out, right? That's because their blood doesn't travel, right, in specialized blood vessels, right? All the oxygen is all over the show. It's dissolved in the fluid, and that we call an open circulatory system. You'll hear about a hemocole when you get to grade 11 next year. You'll start to learn more about the structure of the insects. If we look at a closed circulatory system, here I've got a picture of a fish. All right, you will notice, quite simply, blood stays in blood vessels. We've got a heart that's going to pump, all right, the blood around. It's going to supply enough blood pressure to get all the oxygen to all the parts of the body. And that is very important, to get oxygen, all right, there as soon as possible, and obviously to take the carbon dioxide and the wastes away. Okay, now, right, when we start with the studying of the heart, the first thing that you should do is you should have on a piece of paper, all right, you can get a big A4 one or an A3 paper. You can draw freehand, or if you're not very good at drawing, you can photocopy, all right, a picture of the heart, but you need to study in pictures. It's one thing I cannot stress enough. All right, you guys have done this. You need to have a diagram of the heart, all right? So when you look at it, you can associate labels. So when we look at it, all right, you need to know the external structure of the heart, because here specifically, all right, we always tend to color code, all right, when it gets to the heart, because the reds and the blues, we know the blue is deoxygenated blood and the red is oxygenated blood. And that tells us what different blood vessels are involved. It tells us what side of the heart the blood is going to flow, and that is going to be so important when you have to answer certain questions. Okay, so the first thing you do on a piece of paper, it can be stuck to the ceiling of your room or all over your room, you should have, all right, a picture of the heart with labels. Use color, all right? You don't always learn in paragraphs. That comes later. Have an idea in the picture of your mind what you want to do. Okay? And there we go again, when we look at the internal structure of the heart. Once again, you can have it on the same piece of paper, or you can have it on a different piece of paper. But again, draw. It doesn't matter if you can't draw that well. It's not about your drawing. It's about the information that you are trying to get across. And as you will see, once again, right, we are using the reds and the blues. So we know that the blues are the deoxygenated, all right, blood, and we know that the reds are oxygenated blood. Then we know that the blue is always the right-hand side of the heart, and the red is always the left-hand side of the heart. Because sometimes we get confused when we're labeling. We think that because this is our right hand, that's the right and that's the left, and we forget that it's a mirror image, and we need to cross over. That is the right, and that is the left. Okay, so once again, use color, the reds and the blues, so we know. Now we're going to go on to our first question. Okay, and if you can see there, what have I given you? A very plain, simple diagram of the heart. Okay, you guys, there are so many questions that you can ask. One of the things that you should also maybe invest in is try to get some study guides, or maybe your library at school, collect past papers. Right? Go and get those, or go and ask teachers if you can have copies, and then try and see the different kinds of questions that they can ask you, so that you're not just bogged down to certain questions. Okay, I've chosen fairly simple ones for you tonight, just so that we can get into it and we don't start off in too difficult a note. All right, so if we look here at the heart, all right, already what you should be seeing, you should be concentrating on, if you look at the labels, we can see A and B are the atria, right? The top chambers of the heart, the atrium. If we look at C and we look at D, we're looking at the bottom chambers. They are the ventricles, all right? Then if we look at, remember, the heart brings in, all right, oxygenated blood and deoxygenated blood, and it needs to pump it out again. So we look, there's a label X here. So we really should be thinking to ourselves, okay, that's coming into the heart, and it's coming onto the right-hand side of the heart, so it should be a vein. Remember, veins come to the heart. If we look over here, we see we've got another letter, Y, and we see that it's coming from the left-hand side of the heart, so we know it's going away out of the heart, so we know it's an artery. So the chances are it's going to have oxygenated blood. So already, just by looking at the picture, you should have a slight idea already of what they can ask. The other things that we should notice when it comes to the heart, the valves. All right, as you can see over here, the valves are also going to play an important part, because if they are open or closed, that will give you a great idea, okay, of whether the heart is in relaxation, right, diastole, or if it's contracting, which is going to be systole. So let's have a look at the questions and see if you guys can answer them. All right, the first one is a simple table. So let's get our pen so we can start to, right, let's choose pink for today. Okay. You have to look at the diagram, and it says to you, complete the table below to show whether the valves are open or closed. Okay, so you have to look at the valves. So now we know the valves are going to open and close, all depending if the heart is contracting or relaxing and which chamber it is. But it goes on to tell you something very specific. It says when the pressure in the chamber C is at its highest. So if we go back to the picture over here, we're going to see there is chamber C. Okay, so it is on the left-hand side, so we know that if it's under pressure, all right, sorry, let me just go back there for you quickly. All right, let's go back one. Okay, so if we are under pressure, what are we having? We have got ventricular systole. All right, so the walls of the heart, remember the left side, much thicker because it has to pump more. All right, the walls of the heart are contracting, they're squeezing. Now it asked you, which of the valves are going to be open and which of the valves are going to be closed. All right, so if we were to go there, between chambers C and B, all right, that would be over there. Okay, so if this is contracting, okay, systole, you definitely do not want to have those open, because remember, what is the function of the valves? To stop backflow. All right, you don't want the blood to go in and then to go out again. The whole process, you want it to get in and out of the heart as soon as you can. So for our first answer, if we look over here, then of the first one, between chamber C and B, you would want it to be closed. All right, then between chambers D and A, let's go back up again. It's the same. The heart must mirror each other. Right? What happens on the left side also is going to happen on the right side. So if the valves were closed there, all right, your atrioventricular valves are going to be closed on the right-hand side as well. All right. Now remember that valve, tricuspid valve. Always remember the R, all right, stands for right-hand side. So that is the tricuspid valve. So that valve would also be closed. Okay, now we are going to look at vessel Y, C and Y. So if we go back up again here, look, where do we want the blood to go? We want it to go out of the ventricle into the aorta, all right? And Y is the aorta. So if we want to get into the aorta, it would make much more sense if our valves were open, our semilunar valves, our aortic semilunar valve, to be specific on this one. All right, so our answers there would be the atrioventricular nodes, valves would be closed, and our semilunar valves are going to be open. Okay, let's carry on with the next question. All right, same diagram. Right, and the question is, a large amount, explain the advantage. Okay, so why is it a good thing? All right, that there's a large amount of elastic tissue in blood vessel Y. Now, if we go to blood vessel Y, all right, what do we notice? It is an artery. So even though we're asking a question on the heart, all right, we're linking it with the blood vessels. And when we looked at the blood vessels, right, you notice that there was a difference between the muscular elastic artery, right, that had to pump the blood to the body, and then the vein, which had a much larger lumen and not as much elastic and not as much muscle, because it was under much lower pressure. So here they're asking you, why is it very important for arteries to have the elastic tissue? All right? Can anybody think of the answer? Yes, you're quite right. It's to maintain a high pressure. All right? Because if you have, imagine elastic stretches, all right? But it doesn't, in the arteries, it's not going to stretch as much. So we still retain a little bit of pressure there to get the blood throughout, okay? Because where do we want to get it? We want to get it to the whole body. All right, so the more elastic, the higher the pressure we're going to maintain in the arteries. All right, we are going to then be able to get the blood to the whole body. Okay, that's what we want to do. We need to get the oxygen to all of our cells. If we look at the next question, all right, valves in blood vessels such as blood vessel X. Okay, again, we're tying it up to the blood vessel section. All right, and if we look at X, as I said to you in the beginning, you see it's entering the right, and then we know that then it's going to be a vein. Okay, veins are under much lower pressure. And why do we need to have valves, all right, in the veins? Quite simply, what do we want to stop? All right, sorry, there we go. Okay, let me just try and erase that for you and make it clearer. Okay, we want to stop backflow. All right, that is the most important thing, because the veins are they're not under as much pressure as the arteries, as we know. All right, we need to have valves that if the pressure should drop, the blood doesn't sink all the way down. We wanted to get that deoxygenated blood to the heart, all right, to the lungs. Let's go on to the next one. Okay, Still with this question? All right. Now, a little bit of an interpretive question. If you had a look at those two questions, all right, you would have done, it's a theory work that you have done, okay? Here, again, what they're giving you a scenario. What would be the effect on a person having a hole in the septum between chambers C and D? All right, so over here, there in the muscle, in the septum, remember septum divides the right side from the left. What will happen if there's a hole? Okay, think, all right, what comes in this side? Deoxygenated blood. So what happens is deoxygenated blood will then travel from the ventricle of the right-hand side to the ventricle on the left-hand side. So all of a sudden, this horrible carbon dioxide-filled air, all right, instead of it going to the lungs where we can get it oxygenated, it's then going to move into chamber C. So what's going to happen? You're going to have less oxygen. So if we have to write the answer down, I'm going to use an arrow here. You're going to have a decrease in oxygen, all right, going through to your body because it's going to be filled with carbon dioxide. And what's going to happen when you don't have enough oxygen? You don't have enough oxygen for cellular respiration. What starts to happen? Yes, all right, you are going to feel tired, lethargic, all right? It's like you haven't got enough energy. Okay, so they obviously would then want to be able to, if they could, to fix that. Okay, so we don't want the deoxygenated blood going to the left-hand side of the heart. Okay. All right. Now we've dealt with these a little bit, all right, when we started with the question on the heart. And what you would have noticed, as I say to you, you can't study the circulatory system, all right, in boxes. You need to concentrate on the heart, but you also know that the questions that we ask now also related to the blood vessels, right? So if we look at an overview here of the blood vessels, what will you notice? Terms again. You need to know the terminology, right? We said that arteries come from the heart. That is what an artery is. Not always carrying oxygenated blood. You know there are a few exceptions, the pulmonary artery, for example. And then it goes to the smallest cells, okay? So blood vessels, they're like the highway system on our roads. We've got it big, the N1, traveling, lots and lots of traffic. But as you get closer and closer to your house, so the roads need to become more specific and smaller. And that's exactly what happens here. An artery becomes smaller, all right, into an arteriole. Arterioles become capillaries, which are our smallest blood vessels, and there we know what's going to happen. Diffusion, oxygen and carbon dioxide are going to exchange, all right, wastes are going to move out, nutrients are going to move in, so very, very, all right, important there. They are then going to go into a vein, all right, and the vein is then going to take all that deoxygenated blood and veins to the heart. All right, so venule and then into a vein. Okay, so there we've got the arteries, the capillaries, and the veins. Okay.
Do you think we can give a little bit of an ad break?
I think an ad break at this stage time would be absolutely awesome.
Yes, before all their veins are
Before
overloaded
all
with
the veins
information.
just explode.
All right. So on that note, mindsetters, as I always say, do not disappear. Yes, fair enough. Go do whatever you have to do. Go to the bathroom, go get a snack, whatever. But make sure you come back after this ad break. We'll see you soon. Cheers.